Hi students, today I am going to explain what is resonance energy. Okay, so first let's see what is resonance. So the structure of some molecules and ions are not adequately represented by single Lewis structure. So we cannot represent the structures in only one structure, Lewis structure. So that molecules are ions. What is resonance? So the structure of some molecules and ions are not adequately represented by a single Lewis structure. So we cannot represent the structures in a single Lewis structure, but we can write it in terms of two or more Lewis structures. So it is called resonance. So we can define it like this. Resonance is a method of writing or describing the molecules or ions in a two or more Lewis structures. For example, nitrogen dioxide, see, we can represent it in three structures. So double bond is rotated. So in these two structures, double bond here with this oxygen atom and with this oxygen atom. So it can be rotated with these two. So like this we can represent, and because of this resonance, what happens? The energy of the molecule is lowered and acquires minimum energy. So and this minimum energy which is acquired because of resonance is called resonance energy. Why it is acquiring the less energy? You have to just think why. Because we can see here double bond, it is rotating in a molecule. So when it is rotating, it will consume some energy. So because of this, the energy will be becoming less. Yes, no? So the resonance structure will be having less energy than the individual forms. So you understood what is the reason? So the reason is just because of the double bond which is rotating around the bonding between the atoms. That is why the energy is lowered in a molecule, and this minimum energy acquired in a resonance structure is called resonance energy. Then according to the resonance energy, according to the VBT theory, what is VBT theory? Valency bond theory, we know that. So in H2 molecule, in hydrogen molecule, when we see according to the valency bond theory contribution, where the ionic form is H plus H minus and the covalent structure is HH covalent bond, we know that. When we consider these two forms once, then the phenomenon is called covalent ionic resonance structure. So in a hydrogen molecule, when we take both the ionic form and covalent structure, no molecule is purely covalent or purely ionic. We know that all the covalent molecules will have little ionic structures. Yes, no, they will become ions because they are not equally distributed. They will get little positive charge, little negative charge. That's why they will become ionic form. Even the ionic forms will also may become covalent have. So both the ionic form and covalent structures together, according to VBT theory, we will consider, and this phenomenon is called covalent ionic resonance structure. In this, the Lewis structure can be expressed as a linear combination of separate wave functions expressing individual structures called canonical forms. So according to this theory, we will express we can express it is a linear combination of all the structures. So all the structures by linearly combining the separate wave functions, expressing as an individual structure. We will understand it when I explain this. And these individual structures are called canonical forms. For example, so we can write canonical forms C1 Psi1 plus C2 Psi2 plus C3 Psi3, etc. How many resonance structures it will take? That many. So for example, if we take CO3, 2 minus carbonate ion. So CO3 we can write first possible structure is here double bond, and these two are negative charge, and here double bond, again these two will be having negative charge, and here double bond. So three resonance structures are formed. These are three canonical forms, and Psi1, Psi2, Psi3. So all mixed linear combination of all this is Psi is equal to C1 Psi1 plus C2 Psi2 plus C3 Psi3. So with combining all this, we will get So the bond is rotating around these three forms. So this is the resonance resonance structure. It is a linear combination of this structure. So we already know that the resonance energy is the minimum energy acquired. So it is the minimum. So we know that resonance is the minimum energy obtained after the all the resonance structures we combined. So we can say like this: resonance energy is the energy obtained from the actual wave function, which is a linear combination of the wave functions representing in canonical forms. So it is always lower than the individual canonical forms. So we can say this will be having lower energy than individual forms. So and E resonance is equal to, we can express it as energy of the most stable canonical form, so minus energy of the actual molecules. So energy of the most stable, this is a stable form, minus energy of all the actual molecules. So like this we can calculate. I'm explaining it with some examples. Resonance, for example, carbon monoxide if we take. So carbon monoxide, we can represent it with two structures. So double bond here we can see and here we can see one arrow. So it is containing O plus, means the lone pair of electrons. So it is shared back. So and no dipole moment is very small in this structures. Then carbon dioxide, we can see double bond is here, two double bonds, here one double bond and one triple bond, again here triple bond, one double bond. So the bond structures are rotating like this. Three structures is possible and there is no dipole moment in this. Next, nitrogen dioxide, we can see N here double bond and single bond. Here it is single bond, double bond, like this. Two resonance structures is possible with the nitrogen dioxide. So I will explain what is dipole moment, formal charge in the next video. Thank you.